Good evening, Priya. Good evening, Pushpendra. Good evening, Snigdha. Good evening, Katyani. I welcome you all to this live class. Now we have finished electricity and now we go on to the last chapter of our annual syllabus, which is magnetic effect of electric currents. Okay, before I go there, I'll just ask you one last time. Anybody has any issues in electricity, any topic which you feel you haven't understood and you feel that it needs to be explained again, or any numerical you need to know how to solve it, you can always send those queries to me, right, and I'll address them. Good evening, Siddhant. Good evening, Ashi. Okay, anybody has any problem in electricity can quickly write to me, otherwise we continue with what we have decided. We go to the next chapter, chapter 13, magnetic effects of electric current. Okay, now earlier we used to think that the phenomena of magnetism and electricity are altogether different. Okay, Snigdha Siddhant say no sir, all clear. Very nice, I'm happy. We've understood everything. In case some question comes up which you feel you need my help, you can always write about it to me, right? So I was telling you that earlier electrical phenomena and magnetic phenomena, they were treated as different fields and people used to study them differently, okay? They used to study them separately, okay? But just then Sir Hans Christian Ørsted accidentally discovered that these two were actually related, and he told the word. Okay, Shlok also says no doubt sir, very nice, proud of you Shlok. Janvi, good evening, welcome to the class. Okay, so we start with the activity. We do a activity 13.1. In this what we do is we connect a battery with a plug-in key and a resistor to ensure that a limited amount of current flows. We could make it a rheostat wherein we could control the amount of current passing through the conductor. Okay, and then we connect a copper wire between the two ends, free ends. Okay, copper being a good conductor, we keep a wire of copper in the between the two ends XY, and then we place a needle. Okay, we align all this in such a way that our conductor is in line with the needle. Okay, a magnetic needle, when you keep it freely, it will generally point towards the north like this. Okay, so I keep the magnetic needle and then align my wire alongside it, keeping it parallel to it. Okay, so this is the copper wire in XY and I've aligned it with the direction in which the magnetic needle was pointing. Now when I plug in the key, when the key is closed, when the current starts flowing, then I see that the needle is showing a deflection. Okay, I see that the needle is showing a deflection, which means that when current is passing through this copper conductor, then it is producing a magnetic field. I reverse the direction, which means I change the battery, I take the negative that side and positive this side. Then I see that the direction in which the needle was deflecting also changes. Okay, good evening Sujal Tiwari, good evening Saurabh Shukla. So from this activity we learn that electric current produces magnetic field. Okay, Sir Hans Christian Ørsted was the one who told about this to us first of all, and he had accidentally discovered that electricity and magnetism were related phenomena. Okay, now we go to activity, next activity. Before going to next activity, just let's understand what is magnetic field and what are magnetic field lines. Okay, let's understand what is magnetic field and field lines. Okay, we all are familiar with a compass. Okay, we just discussed that it points towards the north. What is the compass needle? The compass needle actually is a very small magnet, okay, which is suspended on a pivot, okay, and it gets deflected when it is brought near a bar magnet. Okay, if I have a bar magnet, this is the north and this is the south, and I bring my magnetic needle close to it, okay, then it will point away. The north pole will be pointing away and the south will be towards this side. Whereas if I keep it this side, then the north will be pointing towards the south, okay, and the south will be pointing away. Got it? So we know that opposite poles attract each other, and like poles repel each other. Okay, the pointed end, the red arrowhead is always the north. So you can see that the red arrowhead is running away from the north pole of the magnet. Okay, and this side you can see that the red arrowhead is now getting attracted towards the opposite, that is the south pole. Okay, a compass needle is in fact a small bar magnet, and the ends of the compass needle point approximately towards, I told you they point approximately towards the north and south directions. The end pointing towards north is called the north seeking. This is called the north seeking, okay, or simply the north pole. It is called the north seeking or simply the north pole. Okay, and the other end which points towards south is called the south seeking or simply the south poles. Okay, now we go to activity 13.2. Now that we have understood how a magnetic needle works, okay, and so now we go to activity 13.2. Now we try to find out what the magnetic field is and how it looks like. Okay, so what I do now is I'll change the color. This is a bit too dark a color. Okay, I take a sheet of paper, okay, and on this I place a bar magnet. Got it? And then I sprinkle some iron filings. Okay, when you file iron rod or anything made up of iron, you get small pieces out, okay, which are known as iron filings. So I keep these iron filings on the sheet of paper, okay, and then using my finger I start tapping it. I tap it, tap, okay, and what do I see? I see that now all these iron filings are arranging themselves. Okay, you will see needle-like structures forming on either side. You will see needle-like structures forming on either side, okay, which are turning around here. So these iron filings, they start arranging themselves. The iron filings arrange themselves in a pattern as I have made over here, okay, circular, somewhat circular, starting from the poles and then moving out. Okay, now why do these iron filings arrange in such a pattern? What does this pattern demonstrate? Okay, they arrange in this pattern because actually the magnetic field lines are circular like this. Okay, starting from the north pole they run up to the south pole. Okay, so these iron filings now are aligning themselves with these magnetic field lines and arranging themselves. So these iron filings actually are showing us the magnetic field lines. The magnet exerts its influence in this region, okay, surrounding it. Therefore, the iron filings experience a force. The force thus exerted makes iron filings to arrange into a pattern. The region surrounding the magnet. Now, this is the region, okay, up till where the iron filings are experiencing a force. Okay, so this region surrounding the magnet up to which the iron filings experience a force is known as the magnetic field. वो इलाका जहाँ तक इस magnet का force experience किया जा सकता है, that entire area is known as its magnetic field. Okay, the lines along which the iron filings align themselves are called the field lines. और ये जो lines जिसके along वो align कर रही हैं, okay, these lines are known as magnetic field lines. Okay, now we go to activity 13.3. You have understood, I suppose, what is our magnetic field and magnetic field lines. So I take you to the next activity, which is activity 13.3. Okay, अब इस activity में क्या करना है? इस activity में there's another method of finding the magnetic field lines. ठीक है, इस activity में अब क्या करना है? I take a bar magnet. Again, I put it on a sheet of paper. Okay, so this is my sheet of paper, and I have put the bar magnet. I draw the outline of the bar magnet, and then I take a compass. Okay, suppose this is the north and this is the south. So I take a compass and I keep it over here, and I see that the compass points in that direction like this. Okay, so I mark two dots, one at the end of the arrow and the other at the beginning of the arrow. Then I lift up this, and now I again keep my compass over here. Okay, and now I see it points in this direction. So again I make 2 points. Okay, one over here and one in front. Now again I pick it up, and again I place the compass over here, and now this time the compass is pointing like this. So I make again dots in front and at back. So when I continue, I've gone out of the sheet. When I continue, so I get dots like this, and finally it comes back to the other pole of the magnet. Okay, so it ultimately comes back to the other pole of the magnet. So what have we done? We took a small compass and a bar magnet. This is the bar magnet, okay, and the green thing is the compass. And then we took place a magnet on a sheet. We fixed on a drawing board. Then we marked the boundary of the magnet. This blue thing is the boundary of the magnet. We placed the compass near the north pole of the magnet. Now we saw that it is behaving, it's pointing away, so we make the 2 points. Okay, and then we picked it up, we placed it in front. We again marked 2 points at the 2 ends of the needle. Now we move the needle to a new position such that its south pole occupies the position previously occupied. Okay, you can see that the south pole over here is occupying the which was previously occupied by the arrowhead or the north. In this way we proceed step by step till we reach the south pole. Okay, now we join these lines. Now we join these points. So we join these points like this. Okay, and this gives us a field line. एक field line ऐसे हमें मिल रही है. Okay, we can do this activity many times and obtain many field lines like this. Got it? So we repeat the above procedure and draw as many field lines as we can. You will get a pattern which looks somewhat like this. Okay, I'll erase this. This has become a bit dirty, and I'll reduce the width of my pen a little, and then I'll draw it. Okay, so now this yellow thing is my bar magnet. Okay, so I get a pattern like this. Okay, now a magnetic field has both magnitude as well as direction. Okay, we say that these magnetic fields are emerging from the north. We say that they emerge from the north and they culminate or they end at the south pole of a magnet. Okay, and you can see that no 2 field lines are intersecting. Okay, no 2 magnetic field lines ever intersect. Okay, and the final thing, you can see that the magnetic field lines are very crowded near the poles, and they are far away away from the magnet. Okay, clear everybody? These few points about the magnets. Okay, so magnetic field is a quantity that has both direction as well as magnitude. The direction of the magnetic field is taken to be the direction in which the north pole of the compass needle moves, okay, which means from the north it will move out, and from the south, because if I place a needle, my needle will be pointing like this over here, and if I place a needle over here, it will be pointing away like this, okay. So the field line's direction is taken same as that of the needle, which means they start from the north pole and they culminate at the south pole. So we take that the field lines emerge from north pole and they merge at the south pole. Inside the magnet, now what happens inside the magnet? Inside the magnet, of course, these will be growing from south to north. Inside the magnet, the direction of field lines is from south to north. So if I connect them, it connects like this, okay, it connects like this. Similarly, this one also connects like this, and inside the magnet the field lines are from south to north, whereas outside the magnet you can see they are from now north to south. The relative strength of the magnet is shown by the degree of closeness of the lines, okay. जितना magnetic lines नज़दीक हैं उतना ज़्यादा magnetic field strength है, और जितना magnetic field lines दूर हैं उतना कम magnetic field की strength है, okay. So you can see that the field is very strong near the north pole and the south pole, but away from the magnet, parallel to the magnet, the field is weak. Here the lines are quite far away, and here you can see there is very little distance between the magnetic field lines, okay. So the magnetic field is very strong near the poles and parallel to the magnet, or it's not that strong, okay. The relative strength of the magnetic field is shown by the degree of closeness of the field lines. The field is stronger, that is the force acting on the pole of another magnet placed is greater where the field lines are crowded. No two field lines are found to cross, okay. Why two field lines don't cross? And the second thing, I told you I'll ask you a few things. The second thing which I'll ask you is that how do I find the direction of the magnetic field over here? Let me put a red mark over there, okay. Suppose I want the magnetic field over here and this place. This is A and this is B. So how can you tell me what is the direction of magnetic field at A and B? Question number one. Question two, how do we say, how can we say that magnetic field lines never cross each other? Waiting for your answer now. I've done enough talking. Now it is your turn to reply. Kushagra says, can you please activity 13.2 once again? There was nothing in activity 13.2, Kushagra. It's very plain simple. We took some iron filings, we placed it on a piece of paper, we placed a bar magnet at the middle, and then we tapped the paper. When we tapped the paper, the iron filings arranged themselves. Now they became like pointed needles near the poles, okay. At A, direction is from north pole to south pole. Others, please shoot. How do I find the direction of the magnetic field at positions A and B? Keep on trying. Whatever comes to your head, say I haven't told you as yet. Snigdha Siddhant say they do not cross each other as it would, the compass needle would point towards two directions, which is not possible, okay. Priya says it is from south pole to north pole. No. The magnetic field line, Priya, can never be from south to north. I told you, we take it in the direction in which the needle points, which means the magnetic field will always be from north to south. So please retract point number 2. Retract not from this text, okay, retract it from your mind, okay. Magnetic field line can never be from south to north, it will always be from north to south, okay. So now you people are not aware, so I'll tell you, I haven't told you, so not your fault. I'm teaching you this to you first time, okay. They are circular, I said, so I can find the direction of magnetic field at this point by drawing a tangent to the circular path, okay. This tangent gives me the direction of the circular path, and I'll always take it in the direction of the magnetic field line, which means from north to south, so the arrow will be pointing that side, okay. And if I draw a tangent over here, it's again like this, okay, and the direction is again in the direction of the magnetic field from north to south. So I can draw a tangent and find the direction of magnetic field at a particular point of the field line, okay. Now like Snigdha Siddhant says that it will I cannot have two magnetic field lines crossing. Just a minute, I'll change the color. They said that we can't have two magnetic field lines crossing each other. What is happening? We can't have two magnetic field lines crossing each other, because then it will show two directions, okay. So how do it will show two directions? You can see that I've made two magnetic field lines crossing. Now I draw this is field line 1, this is field line 2. So when I draw a tangent with respect to field line 2, then my direction will be this. On the other hand, when I draw a tangent with reference to magnetic field line number 2, then the tangent will be like this, then the direction will be this, which shows that the magnetic field is having two directions at this very point, which never happens. Got it? So we say that magnetic field lines never intersect each other, they never cross each other. You must have seen I was taking a lot of precision to ensure that while drawing I do not touch the other line. I took a lot of time and ensured that one field line do not. In the examination, sometimes they ask you to draw the magnetic field lines. They give you a bar magnet like this, okay, and they ask you to draw the field lines, complete the diagram showing the field lines. Now I see children doing like this, okay, they do like this, so they don't get any marks, and then they come complaining कि अरे सर सही तो बनाया है सर, देखिए नॉर्थ से निकल रही है सर, देखिए साउथ में जा रही है, नंबर क्यों नहीं दिए सर, okay. So you can see that what have they done? They have not some do like this, okay, they'll draw like this and like this, okay, and they'll come. So both these are wrong. What we have to ensure is, number one, that they should not be touching each other, each one is separate. Number two, they are crowded near the poles, and as we go away, okay, they also become further away, showing that the field is weakening over here. Everybody understood? Okay, yeah. Shlok says that magnetic field lines go towards the opposite direction from where they originate. So they originate at the north pole, so they will go towards the south pole. But the direction in the midst we can find by drawing a tangent to that circular path of the field line. Okay. Anirudh says magnetic field lines go towards the opposite direction from where they originate. Okay. Both have written the same thing. You must have picked it from somewhere. Okay. And Snigdha Siddhant also say yes, yes. Priya says yes. Okay. Now we move forward. Now we go to a magnetic field due to a current carrying conductor. This is what we are supposed to study. Okay, till now we were revising on what we had studied in our junior classes in class 8. So magnetic field due to a current carrying conductor is what we are going to study in this class. Okay, so let's see how we study it. Okay, now in activity 13.1 we have seen that an electric field through a metallic wire produces a magnetic field around it. We saw that in activity 13.1. In order to find the direction of the magnetic field, let us repeat the activity. Okay, and how do we do it now? Now what I do is I take a magnetic needle. Okay, I take a magnetic needle and I let it point in the north-south direction. I let it point in the north-south direction. Suppose the north is this side. Okay, I keep it like this. Okay, and then what I do is I place a conductor. I place a conductor on top of this. I place a conductor on top of this, which means that the needle is lying on the table, okay, and I have placed a conductor on top of it. Now I attach this conductor with a battery, okay, and a plug-in key, and I attach it with a plug-in key. Now as soon as As soon as I plug in the key, the conductor current starts flowing in the conductor. This is positive, this is negative. Okay, so current flows from this side to that side. Okay, now the needle will show a deflection. The needle shows a deflection. Okay, what is the direction in which the needle will show deflection? Can somebody tell me? Let me see. What is the direction in which the needle will show deflection? Okay, this is the top. Okay, this is the bottom, and this is the left side, this is the right side. Which side does the needle show deflection? To the top, to the bottom, to the it continues to point to the left, or it goes to the right? Try to find out. Till then, I read your activity. What does the activity says? I'll wait for your answers and read. Okay, the activity says take a long straight copper wire, 2 or 3 1.5 volt cells. Okay, so at present you can say that we have attached just one cell, 1.5 volt cell, and a plug-in key. Okay, connect all of them in series as we have already done in the figure, as shown in the figure. Place the straight wire parallel to and over a compass needle. So first I place the compass needle, because the compass needle will always point in a particular direction. I can't change that. It will always point towards approximately the north pole of the earth. So first I put the compass needle, and then I place the copper wire parallel to it. Okay, now plug in the circuit. Observe the direction and deflection of the north pole of the needle. If the current flows from north to south as shown, the north pole of the compass needle should move towards, I'm not saying anything, you'll have to tell me that. Okay, replace the cell connection in the circuit, and this would result in the change of direction of the current through the copper wire. Observe the change in the direction of the reflection of the needle. You will see that now the needle moves in opposite direction, that is towards dash. It means that the direction of magnetic field lines produced by the electric current is also reversed. Okay, I've read out the activity to you. Now let's see what I have my children written. Priya says to the top. Okay, and Snigdha Siddhant say towards the right. Okay, and Pratyush Pandey says it continues to point towards the left. And Anirudh now comes and it says it rotates from top to right. From top to right. Okay, so now I'll give you the answer. Okay, now most children don't know. Nobody gave me the right answer. Priya gave me the right answer. Okay, so how do I know remember this? Okay, I remember this by remembering the swimming rule. Okay, you'll ask swimming kahan se aa gayi yahan pe? Okay, so what I do is I always imagine a person swimming in the direction of electric current. Okay, you know that one hand, we keep on moving the hands like this. So I imagine that a person is swimming in the direction of the electric current. Okay, and I imagine that the current is passing from his feet and exiting from his head. Okay, such that his nose is pointing down. Okay, we always swim like that. We have a reverse stroke also, wherein we are looking towards the sky. But here we are believing that he's doing freestyle swimming, which means his nose is pointing downwards. Okay, so if the current is entering from his feet and exiting from his head, and he's swimming in the direction of electric current, then the north pole of the needle will always deflect towards his left hand. Okay, so this is his right and this is his left, which means my needle deflects like this. My needle deflects like this. Okay, which means it goes towards the top. That is what only Priya wrote, nobody else wrote. Others wrote left, right, something else. Okay, so this is the new position of the needle. Okay, now I place two cells, sorry. I had 1.5, I add one more 1.5. Okay, I add one more 1.5 volt cell, so I make it a battery now. And what do I observe? I observe that the deflection has increased. I observe that the deflection is in the same direction but the deflection has increased. Earlier it was up till this angle, and now it has gone up to this angle. Okay, you can see that it is still deflecting in the direction of the left hand of my swimmer. Clear, everybody? Okay. In examinations, okay, phone is ringing. I'm taking a class. Just ask sir once, what is he saying? Okay. In examinations, most of the times, okay, they give you based on the compass needle. Okay, now they'll draw a compass at the end of the diagram. They mark over here, this is north, this is south. Of course the needle will always point towards the north. Okay, so this is the north, this is the south, and this is east, and this is west. And now they ask us what is the direction in which the needle will point. So if this compass is given, this compass is drawing beside the diagram, then I don't write top or bottom, then I write the needle will point towards east. Okay, because on the top I have east. Everybody understood? And had it pointed down, I would have then written it would point towards west. Okay, we move forward now. I'll just erase everything and I'll reverse the thing. Now you should be able to answer me. Okay, just a minute. Move out and I redraw everything. This is my conductor and this is connecting wire. This will be the battery over here. This will be the plug-in key over here, and I bring it up to here and I put it over here, and I still keep my compass over here. Okay, still my north is this side. Okay, this is north, this is south, this is east, and this is west. Okay, and I still keep the direction of current. No, I reverse the direction of current this time. Okay, so I reverse the direction of current this time, and I place my plug-in key over here. Now let me quickly draw the compass needle. I draw the compass needle. Now you have to tell me whether it will point towards the east or it will point towards the west with a valid proof. Okay, I mean with a valid what will you say, not a proof, with a valid comment, reason, with a valid reason. Okay, waiting for your answers. I'll just go to the Krita screen. My phone has been taken away, so I'll go to the Krita screen and see what are you commenting. Okay, so only Priya has answered. Okay, I'll tell you the reason. Now this time my positive is this side and my negative is this side. You can see the short line over there. Okay, which means this time my current is flowing from we name it this is Y and this was X. So this time my current is flowing from Y to X. In the previous time it was flowing from X to Y. Okay, the wire is still over the conductor. Okay, so if I make a man who is swimming now. Okay, so my man now is swimming in this direction. Okay, my man is swimming now in this direction, this hand and this hand, like this. Okay, so the current is entering from his foot and leaving from his head. Okay, his nose is down. Okay, so now this is his left hand and this is his right hand. So like Priya says, that this time the needle should deflect towards west like this. Okay, so by changing the direction, the needle's deflection changes. Okay, which shows that whatever field the magnet is producing, whatever magnetic field the needle is experiencing, it is because of the field which is generated by the current carrying conductor. I change the direction of current and the direction of magnetic field line also changes. Everybody understood? Okay, we do one more activity before we finish today's class. We got 10 minutes. Okay, so now what I do is Now I try to find out how the magnetic field lines are around a wire. So similarly, like we had done with a magnet, which Kushagra was asking me to repeat, I do a similar thing. Okay, what I do is now I take my conductor and pass it through the paper like this. Okay, I make a hole and I make it pass through the paper. Okay, and then I connect everything else the same way. Okay, now I connect everything else the same way. So this is X. Okay, just a minute, it has become too thin. This is X. I connect the wire over here, I bring it, I connect it to a battery. Okay, and I connect it to a plug-in key, and I connect it to the wire. This is X, this is Y. Okay, that is X, this is Y. When I plug in the key, okay, before that I sprinkle some iron filings on it, and now when I plug in the key, then I start tapping, and what do I see? I see that my iron filings are arranging themselves in concentric circles. Okay, the center is the conductor and these rings are arranging themselves like circles around it. Okay, so I see that these filings have arranged themselves in rings around the conductor, showing me that we have circular magnetic field lines which are concentric to the conductor. Got it? Now I know that the field lines are circular, but what is their direction? Okay, वो एंटी क्लॉकवाइज हैं, उधर से इधर की तरफ हैं, ऐसे आ रही हैं कि क्लॉकवाइज हैं, कि ऐसे जा रही हैं. I don't know the direction. So how do I find the direction? So I bring in a needle now. Okay, I bring in a needle and I place the needle. Okay, I unplug the plug-in key and I place the needle. It will point in the normal direction in which it is supposed to point, aligning with the north pole of the earth. Okay, and now when I switch it on, okay, I see that it points bottom wise. Okay, it points this direction, it points in this direction, showing me that the field lines are in clockwise direction. Okay, so now this is something very important. We will be finishing the class with this. Okay, so how do I get to know कि ये मेरी जो फील्ड लाइंस हैं इनका डायरेक्शन क्या होगा? Okay, so there is a rule known as right hand thumb rule. Okay, right hand thumb rule. Okay, what is this right hand thumb rule? Okay, I imagine myself holding a conductor in my hand such that okay, the thumb is pointing in the direction of the electric current. मतलब अगर ये मेरा कंडक्टर है, ओके, और उसका इलेक्ट्रिक करंट ऊपर की तरफ है, तो मेरी मैग्नेट का जो मेरे हाथ का जो थंब है, ओके, वो इलेक्ट्रिकल फील्ड की तरफ पॉइंट करना चाहिए, वो ऐसे ऊपर की तरफ करना चाहिए. देन द कर्ल ऑफ माई फिंगर्स, मेरी फिंगर्स इधर को कर्ल कर रही हैं ऐसे करके. ओके, देन द कर्ल ऑफ माई फिंगर्स विल गिव द डायरेक्शन ऑफ द मैग्नेटिक फील्ड लाइंस. ओके, तो यहाँ पे आपको एंटी क्लॉक दिख रहा है. वहाँ पे क्लॉक क्यों दिख रहा था? क्योंकि वहाँ पे हमारा जो पॉजिटिव है वो यहाँ पे है, तो करंट इधर से आ रहा है. गॉट इट? एंड नाउ हियर यू कैन सी द करंट इज गोइंग फ्रॉम टॉप टू बॉटम. करंट ऊपर से नीचे जा रहा है यहाँ पे, इजंट इट? सो यहाँ पे डायरेक्शन ऑफ करंट ऊपर है, यहाँ नीचे है. तो आप ये भी याद रख सकते हो, ठीक है, कि इफ़ द करंट डायरेक्शन ऑफ करंट इज अपवर्ड्स, ओके, देन इट इज़ एंटी क्लॉकवाइज. ओके, एंड इफ़ द डायरेक्शन ऑफ करंट इज़ डाउनवर्ड्स, देन इट इज़ क्लॉकवाइज. DC UAC, ठीक है, DC UAC. अगर डाउनवर्ड्स है तो मेरा क्लॉकवाइज होगा मैग्नेटिक फील्ड का डायरेक्शन ऊपर से देखने पे, और अगर ऊपर की तरफ है और मैं ऊपर से देख रहा हूँ तो मेरा एंटी क्लॉकवाइज होगा. मैं नीचे से देखूँगा तो उल्टा हो जाएगा. पेपर के ऊपर से देख रहा हूँ तो एंटी क्लॉक है, पेपर के नीचे से देखूंगा तो क्लॉकवाइज हो जाएगा. Got it? So this so we remember the right hand thumb rule. The right hand thumb rule says that I imagine myself holding a current carrying conductor in my hand such that my thumb is pointing in the direction of the electric current. Then the direction in which my fingers are curling will give us the direction of the magnetic field lines. Everybody understood? Yes, no? No chat since long? What happened? Nobody has sent any chat since long? Quickly tell me, have you all understood the right hand thumb rule? Have you understood how to determine the direction in which the needle will get deflected? And have you understood how to experimentally prove that a current carrying conductor produces a magnetic field? Snigdha Siddhant say yes sir. What about the others? Quickly tell me, I'll finish. I told you this is the last topic of the day. I'll finish here itself. If you haven't understood anything, you can always ask me. I explain it. We still have 2-3 minutes. Kushagra sends me thumbs ups. Okay, the ones who like the lecture, the ones who think that they understood what they had come here to understand, can like my video. Okay, and thank you very much for being with me. I always love being with you people. Shlok also says yes sir, understood. Thank you very much Shlok. So that's all in today's class. We still have 2 minutes left, but I finished the topic till where I had planned today. So I will say thank you very much, and the next time when I come we will continue from here. In case you have any issue, you can always write about it to me. You are not able to solve a question or something, you can always click a picture of that and send it to me on my personal WhatsApp, and I will definitely answer you. Bye bye, see you, thank you very much, Shabba Khair.